use thread 0 to do it, right? But here, because it's private, thread 0 is not able to see. So each of them can see their own, but nobody else can see it. So they have to sum it themselves. Okay, they have to sum it into this sum. And this sum, remember, is shared. This sum is shared. And if everybody is going to sum, are they going to have race condition? Yes, race condition. And that's why this one needs to be in the critical region. So we do everything in parallel, but there's some part of code we put critical region there, and this code to sum is inside here. And because only one thread is going to sum, not multiple, if you put it here, everybody will race. Here, there's no racing, right? Because one person only. So there's no race condition here. Okay? Because only one person. So you put your code to sum here. Now you solve the problem. Okay? Now, do you have fault sharing? No. Because partial sum is individual private one. They are actually very far apart. Okay? So you don't have fault sharing. Okay? So you do this critical region by making this private, automatically you don't have fault sharing. Because fault sharing is because your data is too near. If you put partial sum in private, they are very far apart. Okay, and there's a reason why far apart. I'm not explaining it now, I'll explain maybe later. Why is it far apart? But for now, you just believe me that it's quite far apart. Okay, so it's when you read into the cache, they are not near to one another, and therefore the thread do not need to wait for one another. They can do everything in one go. And when you run, you can compare. The result here and the result here is more or less the same. Okay? So if you see here 16 times faster than the original one, this will be 16 times faster as well. Okay? So what are the things that you need to change? Very simple. You go to the code, you see the shared partial sum, you change it to private partial sum without the S, only one. Okay? And there's a for loop just after the OMP parallel where you ask thread 0 in the for loop to add them up together. Okay? This one is done by single thread. Now you don't do that anymore. Each of the thread needs to sum themselves. But in order to avoid this to avoid race condition, because this sum is shared, you put this code inside the critical region. Okay, how do you put this critical region? How do you define this critical region? You put pragma OMP critical. Is this one. Great. We check it there. If I delete it there, we just check it. It's pragma OMP critical. Okay? We put it here, open brace, closing brace. So whatever code that is inside there is going to be inside will be considered as critical region. And you allow only one thread to enter and get out. Okay? Is that clear? Is that clear? Okay? You try it and let me know. Okay, open up the file. Or maybe I'll help you a little bit, just in case that you're not able to do. Okay, open up this. There's a file there. Just copy and paste. Copy all. Copy all. Actually, I already have it here, but I'm going to start all over again. Don't save. Let me delete the whole thing. Okay, first thing is create a new project. Console L, you can just start here, console L. Click on this, click next. Here you call it Q4 or whatever name that you want. Create. Okay, first thing first, because I made a mistake just now. I was wondering what was happening. First thing, paste the code there. Next, remember to do this. Right click, go down to properties, go to C++, go to language, set this to yes, OMP yes. Just now I forgot this, just now I was struggling, I was wondering why my code was wrong. Actually my code was right, but I forgot to click yes here. Okay? Whenever you create a new project, please remember this. This step is important. Otherwise, you won't see the result. And your result appeared to be wrong. Actually, your code is right, but the result is wrong. Okay, the next thing is I want to change here to 16. Okay? So I change that. And here I want to change also. I will call it complete pi. With foreshadowing. Okay? And it returns double. Okay, it returns double. Okay? Call it compute pi with foreshadowing. Okay, down below, so not below, near to the end here, because I put double, why I put double? Because I want to return the time taken to process it, so that I can compute the performance gain. Okay, I return this. So that is done. I have that. Now I need my main. Okay, my main is going to call this function. Okay, double array mode 1. Array mode 1. Okay, mode 1 is actually for the critical region. So I'm going to copy this. Paste it here. And this one I'm going to call using critical region. So here is a code where you put your critical to solve using critical region. Okay? And right now I can copy this and paste it here. Okay, now I can run this code and check the performance gain. So I print out first the performance gain. The performance gain which is original divided by mode 1 is okay, I'm going to put on next line, okay, and line. Okay, so if I run the code, of course I don't see any performance gain there because it's the same code, but at least I can see I'm not sure why it can be 7 times faster. I'm not sure why there's a lot of performance gain there. Alright, there shouldn't be any performance gain because it's simple. Oh, maybe because my problem size is too small. Okay, go and change the size. The problem size is too small. Okay, change it to 100 million. Okay, 80, 1, 2, 3, 4, 5, 6, 7, 8. Okay, bigger size, then only you can see it's more consistent. The result is more consistent when the size is big. Okay, now I can see that it's consistent. Okay, so this 1.11 time, that means no performance gain there, right? So because it's the same code. Okay, so right now what you need to do is let me mention to you. Here is array, right? You're going to change it to private sum, partial sum, without the s, because it's not array, it's a single variable. But because it's private, every of the thread is going to own its own partial sum. So you're going to have multiple partial sum owned by individuals. So eventually it's the same as this, okay? Except that it's private, right? And then when you want to add it into the sum, make sure that you put this code to add into the sum inside the critical region. Otherwise you have race condition. You will not have a race condition here because it's private, but this sum is shared. So if you want to add this into the sum, you have to add it inside the critical region, right? So the earlier code, it is done using track 0, which is done here. Okay? And this is done outside. This is done outside the parallel code, which is here at the bottom. So you're going to move it inside the parallel code. Move it inside, and you ask each of the track to do their own self. Okay? Ask the track to do on their own, and in order to do on their own safely, without race condition, put the code inside the critical region. Is that correct? Right? So do that, and you'll get the answer. The answer should be at least 3.5 times faster. It can be 4 times, it can be 5 times. If you use your laptop, you might see 16 times faster, or maybe 8 times faster. Because previous student, they see some performance gain there. Okay? Right? So change this code using critical code. Change shared partial sum to private partial sum without the S. And then change this code, which is the for loop. Which is this. Remove this. And then go into your parallel code, create a critical region using this, and put the code that sum this into here. Okay, that means every of the thread need to sum themselves, but it does it inside the critical region, so it is safe to do so without any race condition because it's critical region. Understand? Okay. Okay, try it. Actually, it's quite simple. Just a few changes you can get it done. Right? Try it now. Change this to 100 million. I think I'm going to change the original file as well. Yeah, change it here. Not only that, I want to change this as well. And change this to constant integer. This one, I think I'll put it in better. Okay. I think this, I need to change quite a lot of things. I want to change it. Let me move it back here. Change it with this, remove this. Change it with this. Ah, this is so ugly. Never mind, I'll change something here. I'm going to move this out here. Copy this, paste it here. Remove all this. Remove this. Copy this. Paste it here. This looks so ugly. Okay, another thing is I don't like this one here. Let's move this one here. Because it's too long, you cannot see. I have to scroll here and there. So I suggest this one put outside. Okay, easier to do. You do like this, easier to do. Okay, I'm going to solve that. Okay, this one change. This one change. Yeah, I think this one is good. Oh yeah, another thing that I want to change is this printing output. Here I want to print out set position. This set position. Set to 16 so that you can see in better position. Okay, you see our wavy line there is because this one requires this. So this one is needed. Okay, here you put IO menu. Alright, put IO menu. Okay? That's fine. Better position. Okay, I'm going to copy this. Okay, paste it here. Gonna paste it here and oh sorry, I made a mistake. Here is constant integer. Okay. Okay, this one I move back to the original file. Just in case that you want to run this independently. This one should be okay, so good. Okay, I made some changes here because just now the code is too ugly and it's not optimized. So I put it outside this time. It's much better. Okay, and this one I make it shorter. Okay, and here num threads come from this num thread. So you can copy this code instead of the code just now. Okay, I always save it. It's a new code now. Okay, you just copy paste it here. And then you change back this one to complete pi with file sharing, put it as double. And the return this on time so that you can complete your performance game. Okay? Okay, still get the same result, and my result is no difference there because I did not make any change. Okay, if you make some change on your laptop, it can go up to 16 times, 17 times faster. That one actually depends on your size here. I suggested it increase to 100 million. 100 million is 1, followed by 8 zeros. Okay. Okay, if you run that, then it will give you a more consistent result. Okay, and that is the change that you need to make. This change, okay? It's quite a simple change. solve. Okay. Previously, when we learned, actually we go around the problem using all this informal way of solving. So this is not the proper way of solving. The better way of solving is actually use critical region. So that's why I'm showing you now. Use this critical region. So this critical region is not using this technique. Okay. If you use this technique, that means this partial sum need to be shared. And then you ask thread 0 to do it for you, right?
Yeah.
But here you do it yourself. That means each thread have to sum themselves. That means they have to do this inside this parallel region. Okay? But because if they do it on their own, here you have race condition because everybody is trying to race to write into this shared variable sum. That's why you have to put it inside the critical region. Because critical region, only one thread that's allowed to run. And therefore there is not going to race. Do you get it? Do you get it now? Why is it so difficult? The concept, I already mentioned to you here, see. This one is OMP parallel. Open brace, closing brace.
Yes.
This critical region is inside the OMP parallel. And how do you do? Pragma OMP critical. Open brace here, closing brace there. And the code that is critical region, the one that you do the summing there, put inside here. That's all that you need to do. Very simple. All the code is already written for you. You just need to move things around and then change it. That's all. Wow, your performance so bad. Go back. No more of this. Then you change to private sum. No more array. Is this the code changes that we make? Yeah. You haven't changed at all. Yeah. Okay, here partial sum, right? It's shared. Have we make it private? That's the first question. Second, this is array with the S. This is not array, it's individual. Okay, it's private to individual thread, but each thread has this, so they have their own one. So if you look at all the threads, they have multiple of this partial sum, individually owned. Okay? So eventually it's the same as this as well. Except that this is shared, this is not shared, this is private. But because this is private, you cannot ask thread 0 to do it for you because it's not shared. It's unlike here, it's shared, thread 0 is able to see all of them. Here, because it's private, thread 0 not able to see, so you cannot do this. Okay? You have to do it yourself. That means the thread have to add it into the sum itself. Okay? And it has to do it inside the critical region if it has to run it in parallel. Okay? Is that clear? How do you make it change first? Partial sum, shared, make it private. How do you make it private? Okay, it's array and now it's single. Previously it was array, right now you make it single. And look at the name, without the S. Okay, it's single. Each thread will have its own private one, right? They're not sharing with one another. Fair enough. Okay, so right now we are in parallel code. And this parallel code, they try to add into the sum. But because if they write into the shared sum, they're going to race. In order to not make that race, you have to put that code inside the critical region. Is that correct? Because in critical region, only one thread can run at a time. One thread run at a time, will they race? No, right. They only race when they are run together, isn't it? Right. Is that true or not? In here, if you take this partial sum and add inside here, in here or here, but many threads going to run, are they going to race? Yes, right. So if they race, they will give you wrong result. Okay, so that's why I have to write the code which sum into here in here. Because if you put there, you can see only one thread run at a time. So are they going to raise? Nobody is going to raise because only one person doing at a time. Right? Clear now? Yes. So. Do you get it? Are you glad also? Make that change. I haven't changed yet. I asked you to change. Set partial sum, make it private. Yeah. Okay. This one, why this is outside? This one, in original code is here, after the parent code. Right? It's after the parent code. Why do you need to put it there? Because outside this parent code, only one thread is going to run. It's thread 0 in the main thread. Right? And we want main thread to do it because only one thread is going to sum them. That's why it is not placed inside here, it's placed outside. But this time, because you want to use critical region must be inside the parent code. Okay? And you put it here because you want every of the thread to do it themselves. You don't want thread 0 to do it for you. Okay, so you have to put it inside here, not outside. Currently, you put it outside. You have to move it into the OMP parallel. You move it inside. Now you get the result. Got it? Still figuring out. You got it? You get the result. Because you know, because you run on laptop, if you run on PC, okay, I can see 3% got it working already.
这样我就直接把就是它就一个一个跑，所以就是这种什么直接来这啥都不用发，反正我的运输有肯定是这里有信息。你跟我跑多少？17。真的，那个是钱，然后给这多少倍？给10多倍。现在就是每一个人有高好，你要把每个人说，也是你快有多少倍的意思？不是快有14倍。哦，这个比较大。那3倍的我又跑14倍了。是16倍哦。这个不是有用到还是有？
所以是要讲这个吧，就是感觉这个是哦，这边有线段，OK。当天我这个
明天的就是明天该到来。
这个不是？
是对同一色。SX。所以他给我放过来。
Okay, rename it like this. Compute pi for sharing. Compute pi using history. Okay, and then write the code like this. And then write the code like this. So then you can compare the performance scale. The performance scale, of course, is higher than 1. So some have got 16, which is good.
我没在水，因为我的车我现在能到得出。有16啊？有啊，我刚才在前面。CPU 没有，应该是跑 CPU。
You get it now?
这里哦，这看这个，跑 CPU 它会有时间。平常60钱，想跑60钱也不会看到吗？
下一个比例
No, I took because mine are
You want to try it?
hours minus close. If it goes to 0, temperature drop, makes around shape damage or this is going to affect you. I believe these are motivation. If you wait long enough,
inside everybody do it on their own.
basically the code is
And everybody is not good for it.
the code is
Put outside,
because I do my own. So I have four
one person so that's the reason. But then it's going to be inside because some is shared. And everybody is racing to one point. So you have race conditions. In order to hold race conditions, you have to because in the end, because critical event will only allow one method.
Then right
The rest have to be done in Europe. Only this one needs to be done
now is
Okay, I see some, many of you already get the result. Okay, the next exercise you do on your own is exactly the same. Except that the problem is different. Okay? This problem. Question 2. The code is here. The full code is here. Okay, this one you do yourself. Okay, at home because you can do at home. Okay? You do not need GPU here. Even though with the GPU you can use Colab, right? But the code is already here, and I suggest that you change this to a bigger value. Put another 30. Yeah, I already put for you. Change it to 100 million. Okay, the code is more or less the same like compute path, except that this one is point average. Okay, and the code is given for single thread. This code is for single thread. Okay, so you write the code, solve it using this technique. Okay, use critical region. Okay, for this problem. Okay, the first technique is to use critical region. And the second method is to use OMP parallel. OMP parallel is very simple. Original code is you just add this only, and it help you do all the job. So the second method is very simple. Second method, first method, use OMP critical. The same technique like what you see here. Okay? So whatever you see there, you just convert it. It's just like what you did just now. Okay? So this exercise I let you do on your own. And check the result. I think the result you can compare with the original result. If they are the same, meaning that it's correct. If it is not the same, that means it's not correct. Okay? Alright, I don't have time now. I mark attendance and then we can do. Where we went, sorry. Chan Kian Yu.
我看到了，
哎，有看到了。
张夫润，张卓阳。